In this video, we're going to discuss local and global maximums and minimums in review for critical points and extreme values for calculus. Okay, so from pre-calc, we said that mins and maxes occur at x values. So notice that we have the language at an x value, but the maximum and minimum values are actually y values. So here we have y values, okay, and f of c would be the y value for that maximum or minimum. And when we have locals, we say for all x near c, so this is in an open interval. Okay, so meaning that if this is our maximum, okay, we must have function values on either side. Okay, so endpoints cannot be local maxes or mins. Okay, now on the other hand, globals, or you might also see the language absolute, maxes and mins, same thing, but now this is saying that the function value must be bigger than all other y values. So the y value corresponding to our max or min value must be bigger or smaller depending on whether it's a global max or min. Okay, then I kind of mentioned this before, but all global maxes may be local mins and maxes. We need to check. But it's not always true, okay, because endpoints again would be the counterexample. Okay, so if I find a local max or min, I need to see if they're global maxes or mins, but I cannot say that they automatically are. The reverse certainly isn't true, so if we have a local max, we cannot say it's a global min right away. Okay, so we want to identify the local and global maxes and mins using complete sentences. Okay, so just to review that language, we see that the mins locally are here and here. Over here, this endpoint, it is not, it is a y value that is smaller than a lot of other y values close to it, but again, our definition is that for a local, it must exist on either, the function value must exist on either side. It must be smaller than any other y values in an open interval near it. So here, this is not going to be a local min. Okay, and then similarly I can say here's going to be a max, here's going to be a max, and by that same logic I can say, okay, here this is not not a local max, because again I have to have function values on either side. Okay, so writing these out now in complete sentences, I'm going to say I have a local minimum of -1 at x is equal to -3. Okay, 1 second, I'll finish this other one. Local min of -3 at x is equal to 1. Now notice that in my language here I'm saying the y value first, and then I'm saying, and then I'm saying the x value. That's because again, the min or max is a y value, and then you say it occurs at this. You can also use a point if you want. You can say local minimum at this. Okay, this language is a bit more clear. Okay, and then similarly for local maxes, I can say local max of +1 at x is equal to -1. Local max of, and let's see, this was 5 at x is equal to 3. Okay, Now I need to start to identify globals. So global maxes, mins, I need to look for maxes the largest y value. I don't need it to exist on an open interval. I just need it to be the largest. And then similarly for global min, I need it to be the smallest. Okay, so max globally, you can have multiple of them, and I actually do. Okay. So those two in purple are going to be my absolute maxes, or global maxes. Okay, largest y values. So I would say global max of, and the y value is 5, at x is equal to -5 and 3. Okay, and then also global min of, and let's see, where is the global minimum? It should be right there. So global minimum of -3 at x is equal to at x is equal to 1. Okay, and so this point, it's not a global or local minimum, even though it is it is low, close to it. Okay, so again, that's just a review of the language. Now, in discussing the relationship to extreme values and critical values, we would say that the function value f of c, again, that's just a y value, is an extreme value if it is either a local or global min or max. Okay, those are so local and global mins and maxes as one chunk, we call those extreme values, or we typically say extrema if it's in a plural sense. Okay, now when we want to start to look at existence of global and local mins and maxes, or extrema in general, and so we get this theorem. It's called the extreme value theorem. But if our function is continuous, meaning no gaps, holes, jumps, etc., on a closed interval, okay, so we have to have it closed on both sides, then we get global mins and maxes for sure. Okay, probably local mins and maxes, but we're not guaranteed that. Okay, so when do global extrema exist? On a closed interval. Okay, now we want to ask the same question, when do local extrema exist? Well, those are going to be local extrema are local mins and maxes. Okay, we said, okay, well, if the tangent line slope was 0 at that point, then it's a candidate for a local min or max. So we need a little bit more of a method to start to verify this, but we can use that as a starting place. So now, algebraically, I mean, we've talked about this conceptually. Algebraically, we know how to do this graphically. Graphically is not a problem. Algebraically, local extrema, we want to look at critical points, because again, critical points, remember, that was values f of, or c f of c, such that, undo that, okay. Such that f prime was equal to 0 or f prime did not exist. Okay, so critical points, that would give us the tangent line slope, where the tangent line slope was 0. Okay, so that would be good, a good starting place. For global extrema, certainly critical points would be a good place to look. We might also need to look at endpoints as well. Okay, and in another video, when you discuss the first derivative test, this is going to encapsulate this entire process.